Today, our article is Time Evolution Operator. We are studying the quantum mechanics of Zitli, chapter number 3. The article number is 3.6.1. We know that every system have some quantum states, and with the passage of time, new quantum states evolved, and our purpose is to find the connection between these initials and final states. So for this purpose, we introduce an operator which is called the linear operator or the propagator, which has some connection between these states. We say that our initial state is psi of t naught. This is the initial quantum state of a system, and the final state is psi of t. So what is the relation between these initial and final states? For this purpose, we say that we have a unitary operator or the linear operator u, which depend on t and t naught, where t is the final time of the system and t is the initial time of the system. We can define that the final state of the system is related with these two things, the unitary operator and the initial state. Final state is equal to the initial state of the system, psi of t naught, times the unitary operator t and t naught. We remember that the final time t is always greater than the initial time t naught. And if we say that our times initial and final time of the new state and the initial state are equal, then the unitary operator t naught and t naught will be equal to identity matrix or the identity operator. When we substitute our final quantum state of the system in Schrodinger equation, and be remember that we will use here time dependent Schrodinger equation, not time independent. We have iota h cut curly by curly t and psi of t is equal to Hamiltonian of the system times the state vector, and we substitute these values, the value of final state vector psi of t in this equation. We will get iota h cut curly by curly t. Here the value is unitary operator times the initial state of the system equals to, here is Hamiltonian as it is, and psi of t is equal to unitary operator t into t naught and the initial state of this system psi of t naught. Here state vector on both the side initial state are the same, so we can cancel them, and iota h cut curly by curly t u of t and t naught, here is t naught equal to Hamiltonian of the system unitary operator t and t naught. Here on the left hand side is iota h cut. When we take this iota h cut to the other side of the equation, then it will become 1 over iota h cut into Hamiltonian and unitary operator, which is also called the linear operator. This unitary operator is also called the linear operator or the propagator or the time evolution operator. All of these things are same. Curly by curly t u of t and t naught is equal to this iota on the denominator. So if we want to take it to the numerator, we need to multiply and divide by the imaginary number iota. T and T naught, and this aorta as it is, this is aorta square, which is equal to -1 h cut Hamiltonian unitary operator T and T naught. This T and T naught depends on the time of the initial and final states of the system. Curly by curly T u of T and T naught. Now this equation is the first order differential equation, and if you want to calculate or to find out the solution of this equation, then it will become that unitary operator u of T and T naught will be equal to e power minus aorta T minus T naught into Hamiltonian over h cut, and the final state of the system psi of T will be equal to e power minus aorta T minus T naught h over h cut into the initial state of this system. This is the solution of this first order differential equation, and our purpose was to find out the evolution operator, and this is the value of evolution operator. And what does this mean? Uh, what does it mean about the unitary operator? This unitary operator deals with the initial and final states of the system, that how they evolve. Also, you can understand this lecture. Goodbye for now.